Okay, picture this. You're at the doctor's office, you know the drill, someone's about to draw your blood, and then you see it. This whole rack of little tubes with brightly colored caps. You've got red, blue, green, lavender. It looks like a rainbow. Well, we're going to dive into that today because there is some fascinating and really critical science behind that color code.
So, have you ever stopped to wonder why? I mean, why not just use one kind of tube for everything? Turns out those colors are actually a super important communication tool. They're like a secret language between the person drawing your blood and the lab that's going to test it. And getting it right is key to getting accurate results. So today, we're going to decode that language.
First things first, these tubes are way more than just little plastic containers. They are a really sophisticated piece of medical technology, and every single color signals a very, very specific purpose. So the official name for these things is vacutainer tubes. They're pretty simple, right? Color-coded plastic tubes, rubber stopper on top. But the name itself gives you a clue about how they work. That vacuum part, that's for the vacuum that's sealed inside, which automatically pulls in the perfect amount of blood. But honestly, the real magic isn't the vacuum. It's what's already inside the tube before your blood even gets in there. And that right there brings us to the core of this whole mystery. What exactly is inside these tubes that makes them all so different? Well, the answer is a tiny but incredibly powerful little ingredient. That ingredient is called an additive. You see, each color-coded tube contains a specific additive that's designed to get the blood sample ready for a very particular kind of test. Some of them stop the blood from clotting, others actually speed clotting up, and some just act like preservatives. Using the right tube with the right additive is absolutely essential for getting the right results. Okay, so the most common type of additive you'll find is something called an anticoagulant. Its job is pretty simple, but it's totally vital. It stops the blood from clotting. This is a must for any test that needs to look at whole blood cells, or at the liquid part of the blood, which we call plasma. Without it, your blood would just turn into a solid clump in the tube, and a lot of tests would be completely impossible to run. Now, while there are a bunch of different additives out there, when it comes to anticoagulants, there are really three main characters that show up most of the time. So let's meet them. First up, we've got ETTA. This one is the absolute star player in the world of hematology. If your doctor ever orders a complete blood count, CBC, to check on your red cells, white cells, and platelets, your blood is definitely going into a tube with ETTA. It works by basically grabbing onto all the calcium, which is a key ingredient the blood needs to start clotting. Next up is sodium citrate. And here's where it gets kind of ironic. We use this anticoagulant to test how well your blood clots. Strange, right? It also binds calcium like EDTA does, but it does it in a way that the lab can reverse. This lets them run tests like a prothrombin time, or a PT, to check for bleeding disorders or see if blood-thinning meds are working correctly. And our third major player is heparin. Now this one works totally differently. It kind of supercharges your body's own natural anti-clotting system. Heparin is perfect when you need a plasma sample and you need it fast, for those urgent or stat chemistry tests, like checking electrolytes in an emergency. Of course, it's not all about stopping clots. Some tubes do the exact opposite. They have clot activators, like tiny silica particles, to make the blood clot faster. That's for when the lab needs serum, which is the liquid left over after the blood clots. Some tubes even have this special gel that forms a solid barrier between the cells and the serum after it's spun down. And others have something called glycolysis inhibitors, which stop the blood cells from eating up all the sugar, which is critical for accurate glucose testing. Okay, so we've met the additives. We know what's inside the tubes. Now for the main event. Let's finally connect these additives to their colors and see what story each tube is really designed to tell. All right, let's start with the lavender or purple top tube. This one's got EDTA inside. This is your absolute workhorse for hematology. Then complete blood counts, checking your A1C for diabetes monitoring. It's all about preserving those cells so they can be counted accurately. Next, we've got the light blue top. This tube contains sodium citrate. Its one and only job is for coagulation studies, testing your body's ability to form a blood clot. And for this one, it is so critical that the tube is filled to exactly the right level. The ratio of blood to the additive has to be perfect for these tests to work. The green top tube has heparin in it. This is the tube you grab when speed is everything. It's used for all those stat chemistry tests where you need plasma and you need it now. Think checking a patient's ammonia levels or electrolytes in the ER. Now, the gray top tube, this one's a specialist. It actually has two additives, potassium oxalate to stop clotting and sodium fluoride to stop the cells from using glucose. This whole combo is specifically designed to preserve the sugar level in your blood so the lab gets a super precise reading from the exact moment your blood was drawn. And finally, we have the red and the gold top tubes. These are your serum tubes. They have a clot activator to make the blood clot up fast. And the gold top, also called an SST, or serum separator tube, has that cool separator gel inside. These tubes are used for a huge range of tests, everything from chemistry panels and hormone levels to screening for infectious diseases. So we've got the colors, we've got the additives. We're done, right? Not quite. There is one more secret to this whole system, and you could argue it's the most important one for preventing mistakes: the order in which the tubes are filled. I know, it might sound a little trivial. Why on earth does the sequence matter so much? But if you've ever had multiple tubes of blood drawn, you might have noticed they don't just grab them at random. There is a strict, standardized protocol that everyone has to follow every single time. The reason is all about preventing something called cross-contamination or reflux. It happens because a tiny, microscopic amount of the additive from the first tube can actually cling to the inside of the needle and then get washed into the second tube. Just imagine if a little bit of the strong anticoagulant from a lavender tube got into a light blue tube. It would completely ruin that sensitive clotting test and could lead to a totally wrong diagnosis or treatment. So you can really see the logic when you look at the order. It's designed specifically to prevent that problem. Sterile cultures for testing infections always go first, so nothing can contaminate them. Then comes the light blue tube for coagulation, because those tests are so delicate. After that are your serum tubes, and finally, the tubes with the really strong liquid anticoagulants like heparin and EDTA are drawn last, so there's zero chance they can carry over and mess up any of the other samples.
Okay, so after all of that, what's the big takeaway here? Why did we just spend all this time decoding a rainbow of plastic tubes? It all matters because this entire system, the colors, the special additives, the vacuum, the super strict order of draw, it's just a brilliant piece of medical engineering. It's all designed for one single purpose: to guarantee that your lab results are as accurate and as reliable as they can possibly be. It's a silent safety net that has a direct impact on your health. So the next time you're in that chair and you see that rainbow of tubes, you won't just see a bunch of colors anymore. You'll see a sophisticated language. You'll see a system where every single detail is planned out, all to make sure that every drop of your blood tells the right story and leads to the right diagnosis. It's some truly brilliant science hidden right there in plain sight.